we're going to do several things today. First, we're going to quickly discuss the plan for the rest of the year. Then we're going to take a look at the lab, go through some of the questions, and some of them together. Leave some room for you to work on your own. Once you take your test, we'll go over through that. So you get last question to take out. So make sure you're ready to go. We'll talk about it after class, okay? All right, so let's start by looking at the plan for the rest of the year. So today, or rather yesterday we looked at the introduction to that lab for M&Ms. Today we're going to do the same thing again. We're going to continue with our intro lab for concept 53. We're going to finish that up today and maybe this weekend have some work to do on it. You guys work tomorrow and you work on Monday. Okay, next week the plan is to actually do 53, 54, 55. So we've been doing an introductory lab that introduces us to concept 53. So we're going to actually look at that concept on Tuesday. Then Wednesday and Thursday we're going to look at 54 and 55. Friday you work. Monday is Memorial Day. Woo! Okay, Monday the 28th is Memorial Day. Tuesday and Wednesday we'll do 56 and 57. Thursday is commencement. There's no school on that Thursday. That's not next Thursday, but the Thursday after. Okay, so 2 Thursdays from today. In 2 weeks from today, there's no school at all.
That's the last week of May, right?
That is the last week of May, yes. 28, let's see, 29, 30, 31, 31st. Then on Friday, you guys work, and then all we have left are 3 days there. So we're going to review those 3 days, and then final start on Thursday. No, sit down. You got to come here first. Come on. I'm going to mark you late on the attendance either way. You know that, right? Okay. We're going to have review on these 3 days. Okay? So we're going to review the last 3 days, and then Thursday and Friday starts the actual final exam. Now, to give you guys an exam on these topics, all I'm going to do is make part of your final also count as an exam for the fourth quarter. All right? So instead of giving you a test on 53 through 57, see that? 53 through 57? Instead of giving you a test and then giving you the final again, I'm just going to have questions on the final that are specifically in regard to those topics. And I'll make sure to note it. I'll put a little note on the final that says, the following problems will count as your quiz or your assessment and test grades for 53 through 57. Okay? So you'll see that. So you will have one more test this quarter, but it will not be in class. It'll be during your final. So some of the problems in your final will count twice or twofold. Okay, your final this year that you're going to take is the Crystal Ray exam final for Algebra 2. It's actually quite simple compared to what we've been doing this year. So I expect to get even higher grades than what I got from my last year's final. What I'm going to give you guys is my final from last year as a review for the Crystal Ray final. So if you want to do like a practice on your own, I'll give you the final that I gave last year out, and I'll give that to you guys to review with this year. I also made a review guide last year, so you'll actually get 2 things to review from. And I'll give you those on Monday or Tuesday of next week. Okay, I'm going to print them all off tomorrow and get them all ready.
So we're only taking the Crystal Ray?
Yes, you're only taking the Crystal Ray final during the exam week. That's all you're taking. I'm going to give you my final from last year and my practice back from last year as means of review for the final.
I'm going to add a concept.
I'm probably going to add them to the end. I'll probably add like 3 or 4 prompts if they're not on there. But if there's some that are on there already that pertain to what we're doing, exponential growth and decay, I'll count those as well. Mia had a question. You have your hand up.
No. I have a question. Sometimes we're having to take 2 finals together and a Crystal Ray. How does that work?
For some classes you are?
Yeah.
So I'm sure you're taking your Crystal Ray either in class and then the actual final, Ms. V's final during finals week. That's one way I'm doing it. Or she might be doing, during finals week, an hour of the exam is Crystal Ray, an hour of the exam is her own. It depends on what she chooses. So just ask the teacher. It's up to them to decide. Can you go? You're not during this period. Yours was switched. There's an updated list. I made sure none of my students were leaving class. I switched all you guys. I did. I'm not gonna lie. I didn't want anyone to miss class. So the updated schedule is right here. And right now it's what time? 10:15? Yeah, none of you guys are at 10:15. Mia, take a look for yourself if you want to find yourself. Mia.
Oh, God. You said what?
I'm glad. You're last with me. You're at
You're at 3 o'clock at Rosie. You're at 3 o'clock at Rosie. Mr. Soma put the updates on the You have what?
You can take my place. I'm not going to.
Oh, you have a group test that time?
She said, I already asked, she said if I missed it, she was planning to do my group.
So then you probably shouldn't miss it. So then you just you don't donate blood this year.
I told her that, and she was like, well, my testimony was more.
Why don't you go at 10?
She can take my place because I'm not doing it. I can't do it.
Or 12.
I'm in number 25.
Maybe after this period you can go down and talk to Mr. Somok and see if there's another time period you can take. Okay? But for now, you do not miss your test. Absolutely not. And that, guys, the reason I moved a lot of people was because I didn't want you to miss the second half of the lab, which is the introduction next class. In addition to that, I had some students that were giving blood during calculus, and they're taking calculus final today in class. So I had to move them also. So I moved all my students around.
I didn't sign up for the thing. I didn't give in the sheet that I had to sign. So I don't know what that ended up there.
I don't know either. You can talk to Mr. Somok now.
Alright.
Okay, ask him. I'm not sure. All right, so let's go back to the lab now. All right? So yesterday, what did you guys accomplish yesterday during the lab? You did two things. You can reiterate what we did yesterday during the lab. What were the two things we did? Evan? Any terms, what would you like to say? What were some of the things we did?
We were adding some check.
Yeah, so at one point they were growing.
At one point, it was decaying.
That's okay, good. So we looked at 2 parts of the lab, one with growth, one with decay. Everybody here say 7, 9, 13. Now, what we're going to do today, besides review what the growth factor means, because many of you did it yesterday, we're going to also look into these questions in these graphs. So let's get started. First, Amber, can you quickly give me your data from these ones right here? Just run them right down, and everybody else, please just listen for a second.
2, 4.
Hold on, I said quickly and I'm not ready. I thought this was already up. All right, sorry about that. 2, 4.
6, 10, 13, 19, 31, 43, 65, 95, 127,
1.
47.
All right. So, again, guys, everybody has different data. So your data is not going to look like this unless you're in Amber's group yesterday. Everybody's data is different per group, and that's what we're going to look at in a minute, how we can put all that together. But, to reiterate how to get the growth factor, remember, the growth factor tells all.
Alright, so the number that you have there, you have to find out what gets you to the other number. What do you have to multiply by?
Good. So it becomes this times this number gives you this number over here.
It's just like you know that thing with the factors?
So you're just dividing?
I'm talking about the, I know what you're talking
No, but like if you go opposite. No. Like 4 divided by 2 is 6 divided by 4 is. That should just go backwards.
What am I trying to do?
I've never seen that before.
You have?
Yeah, that's so sharpened. Yeah, you have.
4. Alright, so you know like what gets you from here? You gotta do 4.
Oh, proportion?
Yeah.
I think that if then.
No, it's like
If
whatever.
then or something like that.
His then was, guys, come on. We're doing all talking. You all got up too late. Sit down. 3 of you guys on there. Come on. Write with a pen now if you have to. This is ridiculous. You can't look at this in the middle of class. He's trying to talk, she's trying to talk. Get out.
Alright, so like you see how this is the greatest. I mean, what am I trying to do? 4 of these get you this, right? So you have to times this by 4. Like so, whatever you do down here, you gotta do up here.
Yeah, so it's like algebra pretty much. And that's all it is. Again, it's like saying 3 times x equals 12, and x is 4, right? So you're determining x every time, really. You're saying 1 times what number in the box gives you 2. 2 times what number here gives you 4. 4 times what number here gives you 6. Okay? And that's what you should pick up on as you go through it. So, first you notice that this has got to be a 2, because 1 times 2 gives you that 2. Then 2 times 2 gives you 4. Then 4 times 1.5 gives you 6. Well, you might not have known that it's 1.5, right? So you might say, well, how do you get to 1.5? Look at the equation over here. So we wrote on the sideboard. Our example earlier was 3 times what number would give you 12? If you want to figure out what that number is, what would you do with the 3?
You would divide it.
You divide. Again, if you want to figure out what that missing number is, you would divide by 3. Divide by 3 to get the multiplier. So simply take the number like 10 here and divide it by 6. What do you get when you do 10 divided by 6?
Like 1.5, right?
1.6 repeated.
So that's what the factor is there. Then take 13 and divide it by 10. 1.3. Then take 19 and divide it by 13. 1. What? So what we're getting here are these values that are showing us how much our population has grown by. Now, does anybody know what the value theoretically should be?
50%.
Very good. Why are you getting that? It's not 50%, it's 150%, but I get what you're saying. Where is the 50% coming from?
Like
The 1 point.
What did we do yesterday, guys?
We took the survey between 2 choices, right?
What were the choices?
Up and down.
Up or down, right?
So, yeah,
So what's the probability of getting one of those?
It's not.
So our number that we theoretically want to get is 1.5, because 1.5 really means 150%, which makes sense because the original value you start with is 100%, and you're going to increase it by how much? 50% every time. So theoretically, you want to get 1.5. Amber, what did your average turn out to be when you did it? 1.58? Okay, so for her data, she got 1.58. So that's what you're going to be doing for the growth factor. Is that clear right there? Most groups have did this already yesterday. I think everybody did this yesterday, right? Now, just to show you what that looks like, we're at period 3, right? Okay. So, looking at period 3, Amber, which group was yours quickly if you look at this? Did you end in 147, 139, or 122?
147.
Okay, so you were group 1. So, if I look at group 1 now, if I take a look at group 1, and I see, here's group 1's growth values. Take a look at the formula that I put into the calculator, or into the program. What does this tell you? Divided by. Well, take a look. When I double click here, C6 is right there. And isn't that what we did a minute ago? We did the bigger number divided by the smaller?
Oh, yeah.
That's what I'm doing here. All these has formulas in them. That's why you see this. You can't see this division by 0 explanation because there's nothing there. So it's showing like an error. So all these other values are just showing errors there. So all these values, I can just go ahead and delete them. And Amber, what did you say you got for an average? 1 point what? 1.58?
Yeah.
That's exactly what I ended up getting when I averaged out. So these are all of your growth factors that I saw that we just wrote down, or we started to write down. 1.6 repeating, 1.3, 1.46, as we just wrote down. Here's the average. This is a formula that, look what it says, equals average of what? Well, when I double click this, it's going to tell me I'm taking the average of that whole column. Okay? And whenever there's an empty cell, it doesn't use it in the calculation. When there's an empty cell, it just ignores it. Okay? So you hit enter, and it does the average of that. Well, if I wanted the average of that column, I don't want to type this formula in 5 times. So all I do is this. I see this little, see how it's a plus sign right now? The cursor? When I hover over the corner, what happens to the plus sign?
It gets thinner.
It gets that thinner plus sign. And if I take this plus sign and drag it over, it's going to extend my formula. And what it's done is this. When I click on this one, it takes the average of this column. But for this next part, what do I want this one to take the average of?
That column.
Of this column. So when I double click now, look what it did. It used this column. And when I look at this one, it used this column. So by me clicking here and dragging over, it's extended the formula to use the respective columns. Okay, these two don't matter though, obviously. We didn't have 5 groups. Now, what this does over here, take a look at this now. Read the formula that says average of C3 through G3. Well, C3 is here, G3 is all the way here. So it's taking the average of the first drop for every group. So when I double click here, take a look at where it highlights the blue. It's averaging these values. Well, what's the average of 1, 1, and 1?
1.
It's just 1. So the first value is still 1. But after that point, from that point on, it averages all the numbers. So the average of 43, 49, and 32 is really just 41.333. So what this has done is taken a look at our class data. Then I did what you're going to do next in your lab. Before I get to that, let's go back to our lab. So this is the class average set right here. And this is the average growth value for the class, 1.58, which is fine. Because look at your values. 1.58, 1.58, 1.57. That's why this average is somewhere in between there. Say again? Oh, because group 3. All right, let's go back to take a look at our questions now. The other stuff that we want to go over. Let's discuss these problems here. So, the first question. Can I get a reader for the first question? Where is it at? Yeah, what's up? They put it in. What's wrong?
Oh, I want to
Oh, sorry.
number 2.
Number 1.
Number 1. The number of M&Ms that you have depends on how many drops you have made. Because of this, the number of M&Ms are called the dependent variable, and the drop number is called the independent variable. In the function, we have been dealing with this here. Which variable is the dependent variable, x or y?
So, remember from this year, what's dependent, what's independent? Which is which? X is independent, because it stands on its own. Y depends on X. Remember, you always plug the X in to get Y, right? So Y is dependent. So this axis here is dependent. The Y-axis, that's your dependent. Well, what did they say the dependent one was?
Dependent is the Y. Oh, no, dependent is the number of M&Ms.
What did you calculate?
The number.
Calculate the number of items.
Number of M&Ms. That's the dependent. What was already on the data table there?
The amount. No, the drop number.
The drop number. And that went from where to where?
0 to 50.
Good. So it went up to 15. Not all of you guys use all 15 drops, though. But this is your drop number.
Drop number.
Okay? So what you want to think about is this. Go back to your table. Go back to your table on page 1. And look at the table on page 1. Above drop number, label that X. Above number of M&Ms, label that Y. Okay, label X above the drop number, label Y above the number of M&Ms. Oh, nobody more questions? Hey, where's yours? One. Don't write it down. You can read through it, stay up for long with this, please, because I need it for 7th period next. Oh, that's actually a need in 7th period. It was actually yesterday. So, number of M&Ms are on the y-axis, drop number on the x-axis. Now, if you plot this, and you plot your data points, you would plot 0, 1 first, right? 0, 1. Then what was the next number you had? 1, comma, 2 for your group, 2. What you're going to notice is this. You're going to end up getting an exponential growth. Okay? You're going to see that you're going to have this curve, and what you're going to actually get is exactly this now. And this is why I paused to show you here. That's what you're going to end up getting. But this is the curve for the class. This is the average for all the classes. So what I did was this. If you look at the data. I'm plotting X versus Y. See how it highlights it? I set up a chart, and I inserted a chart, and I did an XY scatter on the chart. And if you look up here, you'll see it. I did an insert of a scatter, and scatter, you'll see the XY. That's the one I did right there. Then afterward, all I did was label my axes. So this is plotting the drop number versus the number of M&Ms for the whole class. You are to do this for your own group. Again, for your group, you have 0 through, 11 or 12 drops. You'll see that on your data chart. You have how many of these you filled in. You might only go up to 12 or something. So this is your X. This is your Y. You're going to graph X versus Y for all these values on the graph on the next page. Okay, that's your first thing you're going to do. So again, this one we answered together. You're going to graph this one, number of M&Ms, drop number. Next, and you're going to do this for the rest of the period. That's why I'm going through this. The third part, what is the growth factor? You know all the growth factors that you calculated? Yeah. Remember how I said take the average? That's what's going to go in number 3. Okay, so Amber, what was yours? 1.58 you said? So that would be for their group, 1.58. Another group was 1.58 also, but then the other group was 1.57. So be careful which one you were. Make sure you calculate it yourself. What is the y-intercept again here?
It's the number of M&Ms.
The y-intercept, not the y-values. What is the value of the y-intercept? What is it? 0, 1, or just 1, that's the set. Again, how do you get the y-intercept for any function? Set?
X is 0.
So look at your data table. When is x 0? On the first try, isn't it? And don't you have one M&M, everybody?
Yeah.
So what's the y-intercept? It's just 0, 1. What does it represent in the lab? The first M&M. The lone M&M that had to reproduce, right? Okay, the first M&M. Now, for the next part is what we're going to look at concept 53 really. This is the function that we're going to use in concept 53. But what we're going to do today is discuss what these values mean. So it tells you, write an equation for the data where A represents the y-intercept and B represents the growth factor. So what was the y-intercept again? 0, 1. 0, 1, so what's the value of it is just 1. So we say f of x equals, and everybody's going to be the same for A. There's going to be a 1 there. Now, B represented the growth factor. So Amber, for your group, it would be 1.58 to the x. Does the 1 really matter? If I'm multiplying, does this 1 really matter?
No.
Because again, it's a multiplication. So we're going to put it there for now, because that was our y-intercept. That was our starting point. Let's put a starting point here. What does the x mean? It's like the y and x value. If you were to plug in a value for x, oh, actually, let me ask you the question. What did we say in the beginning was the independent variable here?
The X.
Which one in terms of this lab? The drop number or the number of drops. So if you plugged in a number like 10 for x, it means you're looking at the 10th drop, how many you would have there. So look at your data. After a 10th drop, Rosie, how many points, how many M&Ms did you have there? After 10 drops? 139. So technically, if I plug in a 1 here, I'm sorry, if I plug in a 10 here, I should get 139. It's going to be a little bit off because we're trying to fit a curve here. Okay? Now, next, the final thing I want you to do, once you come up with this equation, I want you to graph it on your graphing calculator with this data. And that's what I'm going to show you how to do next. That's what this next part is. See this list? This thing called a list here? We're going to do that now. Okay, so everybody take out your graphing calculator. I'm going to use the group that we've been working with, that first group, as the example for this. So everybody can follow along now and then change the data for themselves. Actually, let me ask a question before I start. Did everybody get a growth factor? Does every group have a growth factor? No, yes, I need to answer. Staring at me doesn't help. Your group did. You got your group? You did not. Did you guys calculate all those growth factors on the first page? Good. Okay. So now one, average all of them. Add them all up and divide by minute R. And then tell your group what the growth factors. Like quick, right? Quick. Yes, you did. Okay. So your growth factor, in the sake of time, Jordan, what was your growth factor? Were you with Rosie? And you, Rosie, were you with Amber also?
No.
Okay, so what was your growth factor?
1.58.
1.58. Okay, your group 1.57. Okay, that means that because this, you must have been group 3 then. This must be your data. From 1 to 122, is that your data?
Yeah.
Yeah. And your growth factor turned out to be 1.57. So write that down here, 1.57. Okay? Now, based on your function, everybody go to y equals, please. Go to y equals. Type in. You don't have to put the 1, but put it there just to be safe. I know we don't have to. 1 times, then whatever your growth factor is in parentheses. So for example, 1.58 was that group. You're going to type in 1.57. Okay? Parentheses, caret, x. So we're doing A, again, this is the A value, this is the B value, this is the y-intercept really, and this is the growth or decay factor.
So in the table, you're going to type it?
All you're going to do right now is this, that's it. I'm going to show you in a minute how to do it with a list, it's different. Yeah.
Just see what it look like.
How do you do what? You got it? Normal X, same X as before, it's not a different X.
So you got one.
Okay? Now, the next thing you need to do, everybody together, press the following. Press stat. If you can't see stat, look up at the board, I'm pointing to it right now. Then press enter on edit. Press enter on edit. And you're going to see L1, L2, L3. Does anybody have any information in those already?
Yeah.
Okay, if you do, watch what I'm going to do. Go up to the list number, so highlight the list number, go up to it, press clear, and then press enter. Again, if you have something in the list, go up to the list number, go up to list 2 maybe, press clear, and then press enter. It will clear out your list.
It says start A, right?
I said to press stat,
Start A.
and then hit enter on edit.
Oh,
You should have this now.
yeah.
Okay. Now, list 1 are your X values that you have from your data table. So everybody type in 0 to 15, please, or 0 to however many you went. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Amber, what is your group up to?
11.
Because I'm using your group's data. All right. So I type in 0 through 11 under list 1 for the group I'm writing now. Okay. Again, type in 0 through however many you have.
Hold on, wait. We got 6 in one column.
Under list 1, you're typing in 0 to however many drops you have. Some groups have 10 drops, some have 11 drops, depends. Okay? So depending on your group,
11.
every group had 11 actually. Take a look up here. These are your 3 groups, guys. Now, in list 2 though, everybody's data is different. So whoever in group 1, whoever this group is going to put that in list 2. Others are going to put this in list 2. Others are going to put this column in list 2. So find your number of M&Ms now and type them in list 2. Okay, using your number of M&Ms, type them into list 2.
We got 139, right?
So I got 1, 2, 4, 6, 10, 13, 19, 31, 43, 65, 95, and 147. Now, if your numbers, if you do not match up, you have to go ahead and take a look and see what you did wrong. If you have 11 spots filled here, it needs to fill up exactly. Everybody understand what I'm saying? For every list 1 component, there needs to be a list 2 component. So what's happening right now? This is really your X column, not your Y column. You're putting in your data table into list 1 and 2. Now, here's the cool part we're going to look at. We can graph this like I graphed in Excel. So you guys saw this graph over here on the right? You can graph the exact same thing. Okay? So what we're going to do is exactly that. So at this point, everybody press second quit. There's no growth factor for that one. Leave it blank. So press second quit there. Now, everybody go back to Y equals, please. See plot 1, 2, and 3 up top? Go up to plot 1 by pressing the up arrow key. Then press enter on plot 1 so it highlights it. Everybody see that again. You want plot 1 to be highlighted. So go up to it and hit enter if it's not highlighted. Okay, so plot 1 needs to be highlighted. Next, last step. Press zoom, and the number is going to be 9, but I want you to see what it is. So let's go down to 9. It's called zoom stat. Everybody see zoom stat? It takes statistics, so it looks at your lists. When you hit zoom stat, it automatically uses your lists. Hit enter on zoom stat. And what you're going to see are all the data points you plugged in, and then you know the graph that you put in Y1? That's the line that's cutting through there. So what you've done is fit a curve to your data. You've taken your data and you fit a little curve to it.
Where's the outlier?
Where's the outlier in this one? There's not really an outlier. This is pretty good data, this group. There isn't an outlier here. Okay? There is not one.
And any of your other tests.
There was one or two in some of the other ones, yeah, because there were mistakes that some groups made, but everybody here did well with their stuff. So there are no outliers.
Oh, never mind.
Okay? Any questions on this? All right? So what we're going to do here for this next part of the lab here for number 5 is just draw a sketch of that. So I want you guys to draw a quick sketch. And I want you to show that you had exponential growth and that there was a line that fit through it. That's what's really going on. Okay, you're drawing a sketch. So we've pretty much done the second page together. Everybody okay with that? We've done the second page together. What your goal for the rest of the class today for homework is to do the other parts now, which are the same, but instead of growth, what do we have?
Decay.
Decay. So we're going to now have what's called a decay factor. A decay factor. So let's quickly take a look at the decay factors on this table, and then I'll let you do the rest on your own. So I want another group now. Can I get your group, Brian, from your data just from this column? Just read them off to me.
1, 2.
Page 3. Page 3. Yep, decay. That's right. Good.
141, 89, 40, 19, 10, 5, 3, 3, 1.
All right. So look at Brian's data now. The question now becomes this. What, theoretically, should I lose every time I roll the M&Ms? How many? 50%. Think about it. Shouldn't 50% be heads up? And in this part of the experiment, didn't we remove whatever was heads up?
Yeah.
So 50% should be going away every time. So if I now take the same thing, take the number here and divide it by the number here again. So Brian, 89 divided by 141. What do you end up getting there? 89 divided, you did the other way around, right?
0.63.
Okay. Now, theoretically, the decay factor should be what? What did you say a minute ago? What should the decay factor be?
50%.
Which as a decimal is?
0.5.
And what did we get here?
6.6.
So you're going to see that a lot of these are going to be off, and that's fine. That's totally normal. So then, Brian, tell me, what's 40 divided by 89? 40 out of 89.
140, 45.
Okay, and take a look already. Don't you noticing they're starting to balance out a little bit? So what you're going to do now is take all of your smaller numbers, like 40 and divide it by 89 and put that there. Then you'll take the 19 divided by 40, put that there. And that one's really close, right? What does that become?
46.
46?
Around
That's fine.
48. Yeah.
47?
Yeah.
Okay. So what you're going to get are a bunch of numbers here. You're going to take these values and do what with them again? Average them. You're going to list your average here. Okay, you're going to list your average there. Now, once you get that average, take a look at the rest of the lab. The next part says, what is the decay factor? That's the average. So whatever you got for the average goes right here. Next, what is the dependent variable? What is the independent variable? Again, it should be the same thing. Okay? Dependent is the number of M&Ms. Independent is the drop number still. You're going to graph it together. So now what you're going to notice is, what's your y-intercept this time going to be? Rosie, what was your y-intercept? 0, 139. Brian, what was your y-intercept? What is it? 0, 141. Jordan, what was your, or your name was Rosie, right? Amber, what was your group's y-intercept for this? Yep, what's your first starting point? 169. So we got 169, 139, and 141, right? These are all at different amounts. Now, that's your new y-intercept, which makes sense because that means we're going to start somewhere up here and we're going to drop off. It's going to be decay now. Okay, so take a look at the next problem. If you look at number 4, it says, what is the y-intercept? What does this represent? Every group is going to be different now. So your A value, the y-intercept, is going to be either, in this class I heard 139, 141, and 169. Those were the 3 different values depending on what group you were in. Now you know the A value. So when you write your function here, everybody's function is going to be different. It's going to be, for example, 139 times whatever the decay factor is, say it's 0.52, to the x. Make believe that's what the answer turned out to be. Again, the b value is still the decay factor that you get from your average.
So the calculator is just checking.
The calculator is our way of checking, yes, and our way of graphing them together, exactly. So when you graph this now, if you take a look at my Excel sheet, you're going to notice that for the class averages, the class average, let me delete some stuff that doesn't need to be here, because it's all... We do not have groups 5 and 6.
Yowza.
So take a look. As a class, the average starting M&M value was about 150. Again, I heard 169, 139, 141, right? So the average starting amount was around 150. And as a class, take a look at our growth factor. We want it to be around 0.5, right? Take a look at the data, though.
What should be decay?
Thank you, decay factor. This is, yes, absolutely, decay factor. Absolutely. We want to think about this, and I call it a growth factor because you're like losing growth, which is decay. Okay, that's why it's still listed as growth factor. So we want to figure out what our values decay by. I don't really need these zeros here. Let me get rid of these zeros because those are throwing off our data. Okay, so we end up getting around 0.6 as our decay value. And when we look at our graph here, we're going to see that our graph has exponential decay. So what you want to do for this part is go to your list 1 and list 2 again and put in your new data values. Then go to y1, put in the new function you're going to get from the other answer, and graph that. Okay, the last part is what we just did actually. Use the class totals, collect the class totals for population decay, graph them together, and see what you notice in this case. And what you notice is exactly what we just had here. This is the class values. So what your goal is this. To finish, you have 15 minutes. You can easily finish this. So in 15 minutes, if you'd like to finish pages 1, 2, 3, and 4. Page 5 you can leave for now. We discussed that as a class. Okay? Finish it today. Show me that it's done today. That's fine. If you don't finish it today, have it done by Tuesday. Okay? Is that clear? What are you doing? Yes. If you want to go up and see numbers, no problem. I'm going to stop recording though, so the video doesn't run.